Hi, everyone. Welcome back. We are in grade 5 and we're on the unit review of Unit 5. So these are your requested videos, your requested questions. So keep them coming. If you are still working on the unit review today, which I hope you are, and you run into a hard one, please do request it because likely if you're struggling with it, someone else is also having a hard time with it. And you got to really be bold to say, this is hard for me. I need help on this one. So thanks to all of the people who've already requested videos. I want to shout you out and also encourage you. Keep going as you're working on it. Keep requesting videos. So that's great. So we're going to start right away with number 1. So shout out to Hannah for requesting number 1 for us. Number 1 is an order of operations question. Remember, order of operations means we have to solve the problem in a certain order. And that's not something that we get to choose. There's lots of times where you'll hear me say, you choose the thing that's best for you. You do it in the way that makes sense to you. Order of operations isn't like that. So if we have a problem that has multiple different operations, and what that means is adding, subtracting, multiplying, dividing, we have to do it in a certain way. Any parentheses, we have to solve first. Any exponents, we have to solve second. Multiplying and dividing, remember, they both want to go at the same time. It's kind of like playing kickball where two kids are running up to try to get to be in line first. They're elbowing each other out of the way. I get to go first. I get to go first. That's what multiplying and dividing are doing. So whoever gets there first from left to right, we read left to right. So multiplying and dividing from left to right. So whichever one is there first, you do. Whichever one's there second, you do. Sometimes there's 4 or 5 of them. Sometimes there's just one. And then finally coming in at the end, just like kickball, remember, sometimes kids aren't really excited to play and they're maybe sitting the bench and there's like, you go, no, you go, oh, you go, you have a turn, no, you have a turn. And kind of that's what add and subtract are a little bit like. They're also going from left to right, but they're coming in at the end. And whichever one is on the left at the very end goes first, whichever one, as we go from left to right, they continue to go. So let's look at number 1. Okay, so here's number 1. 32 minus 4 times 12 minus 8. Well, we have to follow the order of operations, so we have to do parentheses first if there are any. There are, so we have to do 12 minus 8 first. Now, what that means is once we solve 12 minus 8, everything else is still part of the problem. So what I like to do is just work straight down and rewrite everything so I have it all coming down. A little bit like one of those video games where things are dropping out of the sky and they just keep dropping and you do part of it, you blast part of it or whatever, and the rest keep dropping. That's really helpful in order of operations too. It's video games and math, I don't know. But it actually is really helpful to keep organized. So I'm going to keep the 32 divided by 4. I'm going to keep the multiplication sign. The only thing I'm going to change, I've blasted this part out of the sky. So this is like harkening back to a video game when I was a kid. This was kind of a long time ago. So 12 minus 8, 4. Am I done yet? No. Now, I need to do exponents. Do we have any exponents in here? Nope. So we're done with that. Sometimes there won't be all the parts of the problem. That's okay. You just skip it then. Now, multiplication and division from left to right. So I have to go left to right as I read. So 32 divided by 4. Well, I know 32 divided by 4 is 8, but I'm not done with this other part, the multiplying times 4. So I have to keep that. Got to keep that. My new problem is 8 times 4. Well, weirdly, then 8 times 4 is 32. So there's number 1. Thanks, Hannah, for requesting it. Okay, our next question is number 2. Thank you to Andrew and Hannah for requesting this one. So shout out to them. It is 40 minus 2 times 10 plus 22. Now, remember, we have to do the order of operations, but sometimes there aren't those specific, sometimes they're just missing. So in this case, parentheses, we don't have any of them. We skip it. Exponents, don't have any of them. Skip it. Now we're on to multiplication and division. So remember, we're going to pass right over the 40 minus because we're looking for anything that's multiplication and division. Here we run into a multiplication. So 40 minus, we keep. So just like that game that rains down and you're blasting things out of the sky, they should actually make that an order of operations game. It's a new word. It's a new, I don't know, maybe you can make some money on that idea or something. Go. So 2 times 10. We can solve 2 times 10. 2 times 10 we know is 20. But we have to keep the rest of the problem also coming down. So we still need the plus 22. We haven't blasted that out of the sky yet. Now we're left with 40 minus 20 plus 22. We don't have any more multiplication and division. We took care of that. The only thing we're up to is addition and subtraction. So we go left to right. So 40 minus 20 is 20. And we still have that 22 left. And now we have 20 plus 22 is 42. If you write it going straight down like this, it really helps you stay organized. Okay, this is number 3. So shout out to Jackson and Hannah for requesting number 3. So thanks. Number 3 says, Simon wrote this equation, x minus 2 equals 7. And then they give us a whole list of things that we want to check to see if are they equal to, do they have the same solution? So could we use the same number for x in this equation that he wrote, but could we also use that same solution in the ones that the ones that are given? So we're going to first figure out this one, and then we'll look at the given ones. So this is some number. Remember, a variable is just some number we don't know. Some number, take away 2 equals 7. So you can see I got our teeter-totter set up. Instead of setting the teeter-totter up, I just put a sticky note in to put equals. So we know that these two things have to balance. So over here, we're going to use fruit snacks today. But today we've got an open bag of fruit snacks because I have to take some out. So we're going to put this x on there, but we know we're not done with that. We have to take some out. How many do we have to take out? I hope you said it was 2, because the problem says it's a mystery amount, and then we take away 2. And then over here, what do we need? I know many of you are going to know this. We need individual fruit snacks, don't we? It's not a mystery number. We know that its answer is 7. So we need to put 1, 2, 3, 4, 5, 6, 7. So there's our fruit snacks. 1, 2, 3, 4. So some number over here equals some number over here, but only after we take 2 away. So we started out with this mystery amount. I reach in there and take 2 of them out. And I mean, if my boys were here, you know what would happen to those 2 that were just removed from the game. 2 of them out, and now it balances. That amount, when we took those 2 away, now it balances. So the question is, if it's balancing right now, how many are over here? Well, it has to be 7, right? And because 7 equals 7, in order to balance, it has to be 7. So we go ahead and take these out, and I will tell you that I stacked the deck on this one. I did open it up and put in the exact right amount. If you just used a random amount of it, it may or may not work out. But 1, 2, 3, 4, 5, 6, 7. 7 in this bag has to equal the 7. And here are the 2 that we took away. So we started out with 9. We took these 2 out to match the problem. X, some mystery number, taking away 2 gives us 7. So now the answer for us here, is X equals 9. So we started out, the X started out as 9, because when we took 2 away, it equaled 7. So our X is 9. Now, what we have to think then is, does that work for the other parts of the problem? So hold on, I'm going to write them on the board a second. All right, let's go through each one. So I've restacked this as 9. Now, remember we found out in the earlier part that there were 9 in there because when we took 2 out, it balanced with 7. So I've restacked that with 9. So let's see if it works with the same X. We're again going to take away 2 on that side, and over on this side is 7 plus 2. So X, we take away 2, and equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Does X equal 9? But don't forget we're saying, does X, when you take away 2, equal 9? So this X, when we take 2 away, does that now balance with 9? It doesn't, because we took 2 away from it. So over here is now 7, and over here is 9. That doesn't balance. So that's a no. Let's go on to the next one. I'm going to set it up a second. All right, 3B. Does X, we know X is starting as 9, does X, if we take away 2 and then we put those 2 right back in, equal 7 plus 2? Well, let's see. Here's 9. So we take 2 out. Now we put those 2 right back in. We put them right back. Does that equal 7 plus 2? It does. As a matter of fact, this is the one where they're showing us using the inverse operation. Instead of just subtracting 2, they're adding 2 on both sides. Remember, you have to do it on both sides. So the reason this one didn't work is because they only added 2 on one side and it tipped the balance. This one started with 9. They took away those 2, but then they stuck them right back in. So this one ends up with 9, and this one started out with 7 plus 2. So that one was 9. So that one does work. All right, let's look at 3C. Some mystery number, we take away 2, we put those same 2 back, and it equals 7. Let's see if that works. Here's our mystery bag. Remember, the mystery bag, I started at 9. So 9, we take 2 away, but we put them back. Does that balance now? We started out with 9. We took these 2 out. We put them back in. Does that equal 7? No, it equals 9. 9 doesn't equal 7. That one's not true. Finally, let's look at D. We started with a mystery number, and that mystery number right now for us isn't a mystery. We take away 2, then we take away 7, and that equals 7 minus 7. So let's get that set up. Here's our mystery bag. Remember, it starts with 9 because that's what we're checking out to see if it matches. We need to take away 2. Here they are. Put them down there. Then we need to take away 7. 1, 2, 3, 4, 5, 6, 7. There they are. And that needs to equal 7 minus 7. Well, here's 7, so we take them all away. Does that equal? Is what's left in the bag equal to what's left on the plate? There's nothing in the bag. We took them all out, and there's nothing on the plate. That is a solution. It's 0 equals 0, which is true. All right, thanks so much. That's the end of our first video. In our next video, we'll start with number 6. So if you're looking for something number 6 and beyond, check out our next video. See you next time. Bye.